David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Today's lesson covers integrals. Now, we talked about these in the last lesson, and we used this word antiderivatives. And I did mention that these are really called integrals. So this lesson, we're going to drop antiderivative as a term that we use in our class, and we're going to just talk about integrals. And this progression is kind of interesting because it would be like if I taught you multiplication, but then when I taught you division, I first called it anti-multiplication. And we got the concepts down, and then I said to you, okay, it's really not called anti-multiplication, it's called division. So that's the same thing with derivatives and integrals. So let's do a little bit of review. If my function f of x is 2x, then here's my rule for finding the antiderivative, and we're going to formalize that with an integral sign instead. My rule is a over n plus 1, x to the n plus 1. So if I do that to 2x, I'm going to get 2 over 1 plus 1 times x to the 1 plus 1, which ends up being x squared. And just to summarize, we can verify that this is right by taking the derivative of this, and we're going to wind back up at 2x. Now, before we go on, there's one thing that's missing. And I boo-booed on the last video. I caught it when I edited it, but I did not catch it in real time. So think about that. What's missing? If this is the antiderivative of this, there's something else I need to put there. And that is the plus c. Because remember, if we take the derivative of x squared, it's 2x. If we take the derivative of x squared plus 92, that's also 2x. So when we're going the opposite way, when we're taking an integral, or the antiderivative, we don't know if there was a constant out there and what it was. So c could be 0, c could be negative 29, c could be the square root of 743.5. We just don't know. So whenever we take an integral, we put a c there. And that's what they mean by the indefinite integral. And truthfully, this is the title of the lesson from our textbook, is indefinite integrals. Okay, let's start talking about integrals first with our notation. Okay, so if f of x is 2x to the third power, there's our function, and we want to take the antiderivative, which means we want to take the integral, then we would write it this way. That's the integral sign. That means we're taking an integral here. Here is our function, which is called the integrand. That's just some vocab. And then we write dx afterwards. And what dx means is with respect to x. So check this out. The way to read this would be find the integral of 2x to the third with respect to x. And the with respect to x means we're just integrating over smaller and smaller intervals of x to find the slope of tangent lines and all that good stuff. So let's do a couple. Okay, here's a couple of them. Let's just go ahead and do this one. I started here. So integral of 2x to the third with respect to x. Go ahead, pause the video, and do that problem. All right, check this out. I did a straightforward plug-in step. Until you get this wired, I suggest strongly that you always do a very straightforward plug-in step without doing anything else. Just plug in your numbers in the correct places. So here is my formula for finding the integral. I just take my power, I add 1 to it, put it underneath my a, my coefficient of x, and then I add 1 to my existing power. And that ends up being x to the fourth over 2. So that's a quick way to take the integral of 2x to the third. Let's have you do that one. Second one. Now, we haven't talked about a specific rule for how to integrate when you have a second or third or fourth or fifth term added or subtracted to the first one. But it's as you would expect. It's like the power rule when moving forward, you just apply the power rule to each term. When you're doing an integration with the integral power rule, if you want to call it that, you do it in the same way. So check this out. My x to the 7th term gives me 1 over 7 plus 1 times x to the 7 plus 1, which ends up being x to the 8 over 8. And then the trick is, with a constant, 9 is the same as saying 9x to the 0. Because remember, x to the 0 is 1. So 9 can be written as 9x to the 0. So what I did here is I put my a, my coefficient, up here, and I have 0 plus 1, that's my n plus 1, times x to the n plus 1. And so that resolves to 9x. Now, I remembered my plus c, and I kind of snuck in my plus c on that one. So again, you can see, I forget this a bunch. You're going to need to get maybe better than me at this. I've got 4 rules for you. That's what we're going to cover in this lesson. We're going to do a bunch of examples on problems that use all 4 of these rules. So let's go over the rules real quick and then we'll get to work. Check this out. Here's the one that we got already. Okay, this is just our kind of a reverse power rule. I like to state it starting with a coefficient of x to the n in there, and that rides on through here. Now our book and a lot of rules just leave that off. So just be ready for that when you look at a textbook. I think it's more thorough to account for the a, because your function, your term with the power, your exponential term, may well have, or probably most often has a coefficient. There is some number out there, a. So I think it's better to recognize that in our statement of the rule. End of the day, you just need to do the math correctly. So however you remember the rule is fine by me. Just make sure that when you do these integrations, you're good. Okay, second rule. This is sort of like a product rule. We have some constant times our function. So this function could be any function, and we have some k outside of the function times that function. So if we're taking the derivative of k times f of x dx, it's just going to be k times the derivative of fx. So you can take your constant out and put it on the outside of the integral sign, take the integral of the f of x, and then multiply your result by k. That's how that one works. Okay, now this one is like addition and subtraction. And I'm going to go ahead and make this a plus minus because it could be plus or minus here. So if we're taking the integral of one function, f of x, plus or minus a second function, g of x, the result is just the integral of f of x dx plus or minus the integral of g of x dx. So it's kind of how you would think that it might work. In fact, this relates to that example, the second example I did on the last board. What I did is I used this rule for integrals. Finally, this one. This is the integral of a constant. Okay, so k is just a number. Notice how I don't have any mathematical operations. I don't have an exponential. I just have k. There's no f of x here. So the integral of k dx is going to be kx plus c. And that's that thing in the last board where we took the integral of 9. We had to recognize that 9 is also 9x to the 0, and then we can integrate that and we can get 9x. So that's what this is, 9x plus c. Okay, so that's what this is. This is if we have k dx, then it's kx plus c. Let's do a couple. First one, take the integral of 6 with respect to x, which is integral of 6 dx. When you get done with that one, do this one. Take the integral of 4t to the third plus 6t squared plus 3 dt. So we're taking the integral of this integrand with respect to t. So pause the video, do both those problems, and come back. Let's see how you did. Okay, this one is integral of a constant. So that one is just going to be 6x plus c. And your clue that it's x and not q or p or y or whatever is that it's with respect to x. So that's your prompt, that your answer has to have an x in it. So pay attention. If I said du, then you would need to put a u there instead of an x there. Okay, so that's our first one. And I remembered my constant. Yay! Okay, this one's a little more complicated. So what I did is I just applied. Remember that when you have multiple terms added and subtracted, then you can just take the integral of each one individually and get your expression and then simplify. So I took the integral of 4t to the third. Here's my plug-in step for that, 4 over 3 plus 1, t to the 3 plus 1. Then I took my integral of 6t squared, that's 6 over 2 plus 1, t to the 2 plus 1. And then I took my integral of 3, which is 3t, and I put my plus c. Now, I have a question for you. Each one of these technically generates a c. So why didn't I go plus c plus c plus c? Because each one generates a constant. But there's a good reason for why I don't put 3 c's out there. If they're constants, they can all be added together to make one constant. Like if this was 7 and this was 9 and this was negative 20, it's going to be one number. So you don't have to do multiple c's. You just carry one c out there. Okay, finally simplifying on down. This becomes t to the fourth. This becomes 2t to the third, and this becomes 3t, and there's my plus c. All right, give this one a try. We have the integral of 2 times this binomial, x squared plus 3x with respect to x, or dx. So go ahead, pause the video. There's a couple routes you could take on this one. Okay, here are the two ways I'd like to show you for doing this one. The first one takes advantage of one of those rules we put on that last board where I had a constant times a function. See, this little part could be considered our f of x, this part there, and that's our k on the outside. So we're taking the derivative of k times f of x. So I can take my k outside, put it there, and leave my f of x, which is just this part, on the inside of the integral, then take the integral of x squared plus 3x, and that's going to end up being x to the third over 3. If you use your rule, you'll get to that one. And then this one ends up being 3x squared over 2. And of course, I brought my plus c down. And so now I can multiply in with my 2 and get 2x to the third over 3 plus 3x squared plus c. And so that's the integral of this expression. Now the other route is I could go ahead and multiply my binomial here, my x squared plus 3x, by 2 before I take the integral. So that ends up giving us 2x squared plus 6x. Now I can take the integral of this expression and I'm going to get to the same spot. The integral of 2x squared is 2x to the third over 3, and the integral of 6x is going to be 3x squared. And then of course I bring my plus c down and I have the same result. So I'm using two different methods, two different approaches to do the same problem. So one key thing, always take a look at the integrand and figure out how you want to deal with it. Maybe you want to simplify it first, which is what we did here, or maybe you want to directly apply a rule, which is what we did here. There's no best way, although some ways would be shorter, less error prone than others, and obviously if you're more comfortable with those, you should use them. Okay, let's try another one. Here is a pretty straightforward binomial. We just have x squared plus root x. So go ahead and integrate this expression with respect to x and come back. Okay, let's see how you did. So my first step, I don't have any rules for integrating roots. So I just have to change it into a fractional exponent. So this is the same as taking the integral of x squared plus x to the 1/2 dx. And this I can do. So I went ahead and applied my rule. X squared becomes x to the third over 3, and then x to the 1/2 becomes x to the 3/2 over 3/2. Now, this expression is problematic. Right away, we have a compound fraction. You want to take care of those. If you take it further, that's good, especially if the prompt is fully simplified. Otherwise, a correct equivalent answer will fly just fine. So what I did is I went ahead and fixed this compound fraction by multiplying the top by 2 and leaving the 3 on the bottom. So I have x cubed over 3 plus 2x to the 3/2 over 3. Now that's much better. Now, simplifying, I have two things that are over 3. So that's really just one fraction. And then I chose to fix this fractional exponent. Sometimes that's a prompt that you'll see. And so what I end up with is x to the third plus 2 times the root of x cubed over 3. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like And if you'd like to help me grow my YouTube channel, please click subscribe.